Now is Mandalorian. And then
Mute yourself.
What are you trying to do?
Baby Yoda.
Just the right microphone. I'm trying to set up this audio for everything. Moving. Alright, you're gonna have to copy that to
Trying to get
everything
into
else.
the Zoom.
Because right now we're set up, that's gonna capture.
Mute yourself.
Just turn it off. This thing that says Spotify isn't actually Spotify with system audio, and I forgot about Zoom doing the ding dongs all the time. I'm not sure when you want to go live. I'll go ahead and put upstairs. Let me know if you need anything, I guess.
All right. Good evening, everybody. My name is Amy Barraclaw. I'm the director of the Edelman Planetarium, and unfortunately, it's looking pretty cloudy outside. We're probably not going to be able to see anything through the telescopes. So what we're going to be doing instead is taking a look at our night skies from our planetarium system. So we're going to be simulating everything that we do here in the planetarium for you. Okay, is everybody able to hear me now? All right, great. So my name is Amy Barraclaw. I'm the director here at the Edelman Planetarium, and we're going to be taking a look at our skies tonight. Unfortunately, we're not going to be able to see the real nighttime skies because if you've had a chance to peek out, you probably noticed that it is pretty cloudy outside. So unfortunately, we won't really be able to look through the telescopes, but Ben West is with me today. He's upstairs in the observatory ready room, and he is going to be popping outside every couple of minutes to check on the sky conditions, and we'll be ready to switch over to the live feed if we happen to get a lucky break in the clouds, though it's seeming unlikely at the moment. Another problem that we seem to be running into is that Facebook Live is not allowing us to do the stream as we had planned. There seems to be a bit of a problem with that. So those of you that are here in the Zoom call, it shouldn't affect you at all. Everybody else, we are encouraging to go to our YouTube page, and it's currently streaming there as well. So hopefully you're able to join us through Zoom, and hopefully Facebook will sort itself out so that we can do the stream tomorrow when it's supposed to be a little bit clearer. Thankfully, the planets, although they are moving very quickly, from our viewpoint it is relatively slow. So tomorrow, which is looking quite a bit clearer, for the forecast, we will still be able to see Jupiter and Saturn close together at that time. They just won't be at their closest approach, which happens tonight. So let me switch our screens over just a little bit. We are going So we are looking at our skies a little bit after sunset. Actually, our planetarium skies should be set for just about now, right around 6 or 6:30 this evening. And you can see here in our planetarium sky, we've got our moon visible in the sky right now. And I could do some pretty cool things with that. I can actually reach into the night sky, grab hold of it, and pull it in a little bit closer so that we can get a good look at it. So if we were able to see this through the telescope, we would be able to see mountains and craters, which we can see as well here in our view. Plus, we've got these darker flat regions here known as Maria. Maria is Italian for ocean, because Galileo thought that these might be oceans of liquid water on the surface. Of course, we know today that it isn't actually water at all, but is instead dried up lava from impacts that happened long ago. Those impacts cracked the surface of the moon, and it allowed for this hot, molten rock to bubble up and resurface the ground. The really wonderful thing about looking at the moon through a telescope is that, particularly on a night like tonight where you're seeing just a partial phase of the moon, if you look right here along the terminator, which is that day-night view, you can actually see deep into the craters to get a feel for just how big these craters are. You can see the shadows in there giving you a great sense of scale inside those craters. I'll go ahead and push this back in our sky a little bit, and we're going to adjust our view, looking up just a little bit. So looking up above the moon, you'll spot this bright red object here in our sky as well. This is our planet Mars. So I'll bring Mars in a little closer as well. Mars gets its red color from all of the iron oxide that it has in its soil. This is just a really fancy way of saying that Mars has rusty dirt. And it's that rust that gives us the red color that we're so familiar with. On the surface of Mars, we can also see that it too has craters. You might even be able to spot a bit of its south or north polar ice caps. Just like on Earth, the planet Mars also has ice caps at both poles, both the north and south poles. But unlike the Earth, these poles are made out of frozen carbon dioxide or dry ice. So there isn't really that much water in these ice caps, although there has been some that we've seen. And if you look, you can also spot these very thin, hazy clouds that can sometimes also be visible on Mars as well. So we'll go ahead and push Mars back where it belongs and change our view again. This time we're going to be looking towards the southwest. We're going to point ourselves at the object that we all had signed up in order to see, right? We all wanted to be able to see Jupiter and Saturn in our skies tonight. Unfortunately, like I said, the clouds just are not cooperating for that, but we can still see them here in the planetarium. So let's go ahead and zoom ourselves in a little bit, because I want to try to simulate, instead of pulling them in really close like I just did with the moon and Mars, what I'd really like to do is try to get a look that would more replicate what we would have been able to see inside the telescope. So we're going to be changing our view, zooming all the way in here to Jupiter and Saturn. So this is pretty close to what we would have been able to see if we didn't have a whole lot of clouds in our skies right now. We've got several of Jupiter's moons are visible with their labels here. These 4 moons are called the Galilean Moons because Galileo first discovered them about 400 years ago. And we can see some cloud bands here on Jupiter, and of course Saturn and its beautiful rings. And if you look very carefully, you might even be able to spot a few of Saturn's moons as well. Now, this is actually a slightly better view than we would have been able to get through our telescopes, or that we can hope to get tomorrow if the weather forecast stays the same. Because here in the planetarium, we don't have to worry about the atmosphere. So our Earth's atmosphere actually filters light from objects in our solar system and out in the universe. And as that light comes into our atmosphere, it kind of shakes causing the twinkling that you'll see when you look at the stars, and it can also make some of the details, like what we're seeing here on Jupiter and Saturn, it can blur them a little bit so you don't get quite the same crisp view that we can see here in our planetarium right now. Now, I'm actually going to return us back to where we just were. I'd like to take a completely different view of Saturn. It's actually one of my favorite objects to look at because when we look at it really close, it looks like we could land on the rings, but that's not actually possible, and I'll show you why. So what I'm doing is turning our planetarium into a spaceship, and we're actually taking off from Earth, and we are starting to fly towards Saturn. So we should be seeing Saturn getting closer any minute now. So here we have a very funny looking Saturn. Not sure what's going on here. So what I'm trying to show you with our Saturn that seems to have fallen into a black hole is that Saturn's rings look solid, but they're actually made up of these tiny little pieces of ice and dust that float around the planet like millions of tiny little moons. So it's a little bit difficult to see here since we seem to have fallen right inside of a black hole. Let me see if I can reset our skies to something a little more familiar. So here we are back just right around now, right around 6:30 is what our skies are set for tonight. We're facing south. If we were to turn around towards the east, we would be able to spot a few other things in our skies, including our first constellation, one of my favorites to look at. So let's go ahead and take a look here at this constellation just starting to rise. Most people recognize it by these three stars here that form a straight line or a belt. Does anybody think they know whose belt that is? Feel free to unmute yourself if you want to take a guess. That's right. Yeah, this is Orion's belt. But Orion is actually a much bigger constellation. It's not just those three stars. There are 7 very bright ones that we see here, plus a few fainter ones around that try to form our constellation. Now, I'm going to try to see if you can figure out what this constellation is. We know that these 3 stars here are a belt, but there are a couple other important stars that we can look at. We can take a look at this star right over here, known as Rigel. Rigel actually means foot. And if we take a look all the way over here, we have another really bright star in our sky called Betelgeuse. Betelgeuse is a funny name just by itself, but it actually translates to something even better. Betelgeuse actually translates to armpit. So that is quite literally the armpit of Orion. So now that we know where his belt, his foot, and his armpit are, we can take a pretty good guess at what Orion ought to look like in the night sky. So we can try to imagine it like this in our skies. Take a really good look here at our 2 stars, Betelgeuse and Rigel. Do you notice that they're 2 different colors? You might be able to tell that Rigel is kind of a blue or white star in the sky, but Betelgeuse is orange or red. And that's actually really important because star color can tell us something about the star. Does anybody think they know what star color can tell us about a star? Exactly, we can tell how hot or cold a star is just by looking at its color. So one of these stars is obviously hotter than the other. Which one do you think it is? Is it blue Rigel or is it red Betelgeuse? That's right, the blue star is hotter than red. This is sort of the opposite of what we normally think of, right? At home, when we want to turn on the hot water, we're going to turn the handle that's red. But if you want to pick the hottest star, or if you want to pick the hottest flame, like on a candle or campfire, you should always choose blue, because blue is actually much, much hotter than red. Once we've found Orion in the nighttime sky, we can use him to find some other things in our sky. Let's take the 3 stars of his belt here. If we were to draw a straight line and point it up in the sky like this, it would point us to this V-shaped group of stars right over here. This forms the face of Taurus the Bull, which we can imagine in our skies like this. On the back of Taurus is this pretty little cluster of stars here that some people think looks almost like a miniature dipper, but it's not. This little group of stars has many different names. We call it M45 or the Pleiades. Some people know it as the Seven Sisters because of the 7 stars that we can see easily with our unaided eye. In Japan, this group of stars is known as Subaru. Have any of you heard of Subaru before? Might be familiar to some car enthusiasts. Yeah, exactly, the car brand. Have you ever looked at their logo? Does anybody know what it is? It's a group of 6 stars with a bright blue background. Let's take a look at M45 a little bit closer. Does that look a little familiar? Here we can actually see where they got the idea for their logo. Now I assure you they are not paying me for this product placement in the sky. And we can see that there are actually a lot more than just the 6 or 7 stars that we see from the ground. Through our telescopes, we can actually see that there are about 300 stars here in this star cluster. Now, I'd actually like to try to fly to this, like we just did with Saturn. Hopefully, though, unlike with Saturn, we're not going to get sucked into a black hole this time. So the Pleiades, when we look at it through a telescope, the stars all appear to be right in line with each other. But of course, that's just a trick of our viewpoint. Nothing is perfectly aligned in the solar system. So you might have noticed familiar Orion has already started to distort itself right over here. The stars are all at totally different distances from each other. And the same is true with the stars of the Seven Sisters as well. They're all grouped near each other in what astronomers call an open cluster. This is a relatively new group of stars. They formed within this cloud of gas and dust that you can see here. That cloud slowly condensed down, forming little pockets where these stars eventually formed. Once they got big enough and hot enough, they actually blew their outer layers of gas and dust out. And what we see is just what's left over here of this relatively new group of hot young stars. So we will slowly fly ourselves back to our skies tonight. once we return, I'd like to take a look at Orion again, because we're going to change our view a little bit. This time, instead of looking at Orion's belt and pointing our stars up to find Taurus, we're actually going to connect the stars and we're going to point down. Now, to really be able to see what I'd like to show you, we'll actually have to stay up just a little bit later. So we're looking at our skies right now at about 6:30. But if I speed up time just a little bit until, say, 8 or 9 o'clock, we'll be able to see this next object beginning to rise. So here we are. This time, we're going to take those 3 stars of Orion's belt, and we're going to point them down to this star right over here. This is a really important star in the nighttime sky. Does anybody think they know which star that is? I'll give you a hint. It's a Sirius star with a serious name. This star's name is actually Sirius. If you don't believe me, I've added a label to the star. Sirius is our brightest star of the nighttime sky, and it's visible here in the wintertime. It's part of the constellation of Canis Major, the large dog. So we can try to imagine our dog here in the sky tonight. If there's a big dog in the sky, do you think that it would make sense for there to also be a little dog in the sky? Probably, right? Otherwise there wouldn't be very much point in calling it the big dog. So you'd be right. There is in fact a little dog in the sky, but it's a little harder to find because it's only 2 stars. It's made from these 2 stars that we see right over here. So now when I play connect the dots, I don't really get a dog, I get a hot dog or a stick. So we need a lot of imagination here to imagine our little puppy in our skies tonight. 2 more constellations that are visible in the night sky tonight are ones that you're probably going to recognize, but they're in the north, so we need to change our view again. Now that we're facing north, you can try to spot these 7 stars here that form a big spoon in the nighttime sky. Does anybody recognize this one? This is the Big Dipper. Now, the Big Dipper isn't actually a constellation. It's what we call an asterism. Asterisms are familiar groups of stars that we can see that aren't officially recognized as constellations by the astronomical community. So we recognize these 7 stars as the Big Dipper, but officially this constellation is much bigger. It's called Ursa Major, or the Great Bear. So we can add a head and some legs to our dipper to imagine our great big bear. Once we have our Big Dipper or Big Bear in the sky, we can use it to find the Little Dipper. All that we have to do is take the 2 stars that we see right here. If we connect these 2 stars in a straight line, we can point them up until we come to this star, a star in the handle of our Little Dipper. Now, this star is also an important star in the nighttime sky. Would anybody like to try to guess what star this one is? Polaris, the North Star, right. Is it a bright star in the night sky? No thoughts? Oftentimes what I hear from people is, yes, Polaris is a bright star. It must be the brightest, right? Well, we actually know that that's not true. We just saw the brightest star. It's called Sirius, and we saw it in our constellation of the Big Dog. Polaris is actually a rather faint star. In fact, from cities, it can be really difficult to see because of all of the lights that we're turning on at night. These lights shine up into our nighttime sky and they wash out the fainter stars and objects that we would see normally in our nighttime sky. This is something which astronomers call light pollution. And it can be a big deal because with all this light pollution, we lose fainter stars. We're no longer able to see things like meteor showers or the rare aurora in the night sky, or even comets. Some of you might have gone out this summer trying to track down some dark skies to go see Comet Neowise, which was one of the first visible, naked eye visible comets that we've had in a long, long time. But to see it, you had to get very far away from city lights. So Polaris is not a very bright star and is often not visible from places like Philadelphia. So why do we call it the North Star then? What's so special about this star? Maybe we can figure it out if we stay up through the night. So we're currently looking at our skies at around 8 o'clock. We're going to stay up through most of the night, and I want you to just watch the stars. What do you notice all of the stars doing? The stars seem to be spinning, right? But watch Polaris, the North Star. Does it move? It's staying still while all the other stars appear to travel around it. Of course, it's not really the stars that are moving. What's moving? It's actually, that's right, we are. Earth is what's moving. We're rotating on our axis, and we happen to have a star showing us where that rotation axis is. So it stays put while all the other stars appear to move around it. This is what causes the sun to rise in the east and set in the west. It causes the moon, planets, and stars to all do the same. They rise in the east and set in the west. But there's one star in the sky that no matter what time of night or what time of year you're looking at it, it's always visible in the same part of the sky. So this is why we use it as a guide for our directions, why we call it the North Star. It's because it never moves. The Big Dipper was actually a big bear. So what do you think the Little Dipper ought to be? Probably makes sense for it to be a little bear, right? But I'm not a very good artist, so my bear actually looks more like a giant squirrel. So you'll just have to trust me that that is a little bear in the sky tonight. I just don't draw that well. So rather than embarrass myself by continuing to look at these squirrel-like bears, what if instead we took a look at all of the planets? What I'd like to do is bring all of the planets together so that we can see how big they are compared with each other. We'll start with one that's not actually a planet at all, Pluto. Then we'll add in Mercury, the closest planet to the Sun, but it's not the hottest. That's actually Venus, because of its thick clouds. Next, we've added in rusty red Mars, and I'm sure you all recognize this next one, our home planet, Earth. Together, the planets Mercury, Venus, Earth, and Mars form the inner rocky planets, sometimes called the rocky midgets, because they're small and they have hard ground that we can land on. Of course, Pluto is not one of these rocky midgets. It's a dwarf planet. It's the first of 5 dwarf planets that we named in our solar system, so Pluto is not alone. There is another type of planet in our solar system. These are the gas giants, like Jupiter, the largest. The other gas giant planets are Saturn, with its beautiful rings. Uranus is actually tipped over on its side in the solar system. And then we have beautiful blue Neptune. These outer gas giant planets are, of course, much larger than our inner planets, hence the name giants. And as you might be able to guess from gas, there's no solid ground that we could land on. These are all made up of liquids and gases held together by gravity. You also might spot that all of the planets, all of these gas giant planets, actually have rings, but only Saturn's are made out of water ice, which reflects lots of sunlight, and why they're so bright and beautiful and even visible from ground-based telescopes. One other thing that we're missing from our solar system is, of course, our sun. Our sun is not a planet, it's a star, just like all of the other stars that we see at night. But the sun is much closer to us, so it appears bigger and brighter than all of the other stars. If we were to bring in some other stars, we would see just how small our sun really is. So I brought in a few other stars, including Sirius, our brightest. Pollux is one of the twin stars in the constellation Gemini. Here we have Arcturus and bright red Aldebaran. Next, we'll add in blue Rigel. This is the foot of Orion that we saw earlier. And if we're looking at his foot, we may as well add in his armpit too, the supergiant red star Betelgeuse. To really be able to see Betelgeuse, we're going to have to do a few things. First, we're going to back away from all of these other stars to try to create a little bit more room. But since really I'd like to compare Betelgeuse to our sun, we'll also get rid of some of these other stars. So let's start to fade some of those stars away as we back up a little farther so we can find our sun again. There it is, that tiny dot. That's our sun. 1,000,000 times smaller than that dot is our home planet Earth. We are so small when we start to compare ourselves to some of the stars that we see in our own Milky Way galaxy. And we get even smaller when you start to consider that the Milky Way is just one of hundreds of billions of galaxies in our universe. Now, with that very sobering thought, we're going to end my planned presentation, but I'm going to open it up to all of you here on Zoom. If you would like to go ahead and ask a few questions, we do have a little bit of time for a Q&A. You can either ask by unmuting yourself and asking a question, or if you feel more comfortable, you can go ahead and ask your questions in the chat as well. Ben is helping me monitor the chat so that if there are any questions there, he'll make sure that I see them and answer them. So at this time, I'm going to open it up to all of you. So are there any questions from anybody? How many Earths can fit in this in our sun? So we can actually fit 1,000,000 Earths into the sun. How many suns into Betelgeuse? I don't know that exact number, but it's, I believe, in the millions. I know we've calculated it out once, but I have not done it recently. But yeah, Betelgeuse is much, much, much larger than the sun, as we can see. Are there any stars bigger than UY Scuti? That's a tough one. The answer is actually we don't know. It's really hard to start measuring measuring size when we start talking about very great distances. A lot of inaccuracies in the measurements start to build up the farther away that a star is. So one of the largest stars that we've measured so far is that star UY Scuti, but we're also only able to see or measure the stars in our own galaxy. So when we're looking at other galaxies, we know that they're made up of millions and billions of additional stars, but they are so far away that we can't actually measure them. So it's entirely possible that UY Scuti is the largest in the Milky Way, but for all we know, there could be much, much larger stars hanging out in some of the other galaxies. What's the latest interesting discovery that the astronomy community has made in 2020? Well, I don't know that don't know of anything that we've done this year. Usually the discoveries, once they're announced actually a year or two after they were actually observed or detected, because lots of work needs to go into confirming the results that we're seeing. So I know some of the big news from last year, of course, was the very first image of a black hole that we got to see last April. They also were recently doing some studies on our planet Uranus and determined that there is a whole lot of methane in its atmosphere, which tells us that Uranus smells exactly like you would think that it should. Just go ahead and let you guys think about that one a little bit. What makes Neptune appear blue? So Neptune gets its blue color from the gases in its atmosphere. It's made mostly of nitrogen. So that nitrogen reflects lots of blue light back to us. So none of the planets are actually creating their own light. They're all reflecting the sun's light. So yeah, it's all created by the gases. Is there life in outer space? Well, we don't know. We haven't yet detected any, but there are some promising places even within our own solar system that we're planning to look. So one of Saturn's moons, Titan, has some methane lakes inside of it, and it's possible that some form of life could be there. Also, the moon Europa has frozen oceans, and underneath that thick frozen ice crust, there is liquid there, and so it's possible something is developing in those oceans below the icy surface. And Mars still remains a possibility within our own solar system for where life could exist too. Yeah, did somebody want to ask a question? For the planets that we've observed to be similar to Earth, are we viewing them thousands or millions of years in the past, and could they be sustaining life now? So, yeah, it's possible. There are lots of planets out there in our galaxy that we know of, and presumably, you know, the stars in other galaxies as well will also have planets orbiting them. The difficulty with finding planets is that planets, as we saw in our demonstration just a minute ago, planets compared to stars are incredibly tiny. So it's difficult to detect them. Right now, most of what we're seeing are the very large planets orbiting other stars, things that are more similar to Jupiter and Saturn than they are to Earth. We are occasionally finding some planets that are about Earth size, but they're not quite as common right now as these very large gas giant planets are that we're discovering. And as you kind of suggest from your question, we're looking at these objects that are hundreds and thousands of light years away. So we're looking at them as they were 100 or 1,000 years ago, sometimes even longer than that. So it is entirely possible that when we're looking at an object, we are looking at it as it was back then and not as it is today. So maybe when we're able to directly image a planet, we wouldn't be able to detect any signs of life. We're not really at that stage of imaging right now in astronomy. We aren't really able to get very clear, direct images of planets. But imagine sometime in the future, as our imaging techniques get better, if we were to look directly at an exoplanet, one of these planets outside of our solar system, we could someday, in theory, start looking for signs of life. And you're right, just because we don't see it now doesn't mean that it doesn't actually exist there. It just means that 1,000 years ago, when the light from that planet left and started its journey towards us, that life didn't exist then. So it gets really difficult when you start talking about life existing somewhere out in the universe, because the distances are so great that there is this massive time delay. Imagine finding some alien life on the closest star to us, which is Proxima Centauri, about 4 light years away. So imagine we detect some signs of civilized life there, some sort of alien that we can talk to. Well, we send out our hello message to them. It takes 4 years to get to them, and then 4 years for them to say hi back. Now, 8 years has gone back, and all we've done is said hello. It's not going to be easy to communicate if we were to ever find any sort of life outside of our own solar system. What would they see in their telescopes when someone is looking at Earth from another star? So, just like we aren't really able to see these exoplanets very well from Earth, I would imagine that it would be the same for some imagined alien civilization around some other star. The easiest thing that they're going to be able to see is our star, the Sun. And then maybe they'll be able to spot Jupiter and Saturn, and as their imaging gets better and better, maybe they'll be able to work their way down to the smaller planets. But we're making a whole lot of assumptions there, the first being that an alien civilization is looking at us. But we have never detected any life so far.
I have a question.
Sure.
How many galaxies are there in the solar system? I think I already know this.
So there are no galaxies in our solar system. Our solar system is our sun and planets. In our universe, there are hundreds of billions of galaxies thought to exist, but we don't have a accurate, precise number of how many galaxies there are in the universe. Our 3-year-old would like to know why Pluto is so small. The Pluto is not the smallest thing out there. So just like when people are born, we get some bigger people, we get some smaller people. Planets are sometimes big, sometimes a little bit smaller. Pluto's pretty far away from the sun, so when it formed, it must not have had as much of that big gas cloud where left over from what really formed the sun. But Pluto, again, it's not alone out there. There are currently, I think, 5 dwarf planets that are officially named in our solar system, along with a few dwarf planet candidates, plus millions and millions of tiny little space rocks, almost like asteroids, floating out beyond the orbit of Pluto. And we call those Kuiper Belt objects. So many of you all learned about the asteroid belt. When you learned about the solar system, you probably learned about the asteroid belt in between Mars and Jupiter. There's a similar belt of asteroids that's called the Kuiper Belt, and that's out beyond the orbit of Pluto. So why was Pluto declassified as a planet? So Pluto, when it was discovered, it was the 1920s or 30s. It was discovered by an American. So it's kind of funny that here in America, Pluto being reclassified as a dwarf planet was just a huge blow to our national psyche, because it was found as the very first planet by an American, the same year that Walt Disney created the character with the same name, coincidentally. So in our national minds, the planet and the character, are just, they're one and the same, right? So when it was reclassified in 2006, of course, America was devastated and none of the rest of the world cared because it made sense. When Pluto was first found, it was thought to be the last thing of the solar system. So adding it as a planet just sort of made sense. It was a big, round, rocky, icy ball at the edge of the solar system. But as time went on, we started finding more of these objects. And it was kind of okay at first, because we were finding things that were smaller than Pluto. So Pluto was sort of the cutoff. Pluto's still the 9th last planet, and then there's these other smaller things out beyond Pluto. But then things started to get really tricky, because a planet, officially a dwarf planet, another object was found beyond Pluto that was bigger than Pluto. So if Pluto is a planet, well, then this object, which astronomers called Eris, which was the god of discord and strife, named because they knew that this was going to cause a whole lot of problems, finding this object bigger than Pluto, because now we have to start thinking, is this a 10th planet? Or we're finding more and more and more of these things out beyond Pluto. Maybe it makes more sense to start changing how we classify things. So Pluto, Eris, Sedna, Haumea, Makemake, Ceres, and a number of other objects all got reclassified as dwarf planets rather than planets. This also allowed for objects like Ceres, which is one of the largest asteroids in the asteroid belt between Mars and Jupiter. Ceres is a dwarf planet as well. So imagine if we were to be adding all of these things we found beyond Pluto, if those all became planets, then we need to really reclassify Ceres, because it's big and round and out there. So now, we're going to be talking about 13 or 15 or 200 planets all of a sudden. So it made a lot more sense to try to reclassify it. If Ganymede lost its grip to Jupiter, would Mercury become a dwarf planet? I'm not quite sure that I understand that question. So Ganymede is a very large moon of Jupiter. It's orbiting around Jupiter. It's not likely to get flung out. So, it's pretty solidly classified as a moon. And Mercury is much bigger than the dwarf planets. So it's probably going to stay as the smallest planet, smallest terrestrial planet, inner planet. Do we need to see light or radiation to identify an object in space? Yeah, so that's right. This question here is about dark matter or dark energy. And this is something that we don't know a whole lot about. Astronomers can sort of indirectly detect it. They can see the effects of this particular thing in the universe, but we don't know exactly what it is yet. But figuring out what dark matter and what dark energy are could be really big keys to figuring out how our universe formed. So that's going to be a big question that astronomers are currently working to solve. What happens when a neutron star dies? Well, actually, neutron stars are already dead. So stars, when they die, very large ones will explode as supernovas. And if they're large enough, then they'll collapse down. The core that remains after that supernova explosion starts to collapse down and form a neutron star. And that's what that neutron star is. It's just this really, really dense collapsed core of a very, very large star. If it's even larger, when it first blows up, it might actually condense itself down so much that it blinks out of existence and becomes a black hole. So neutron stars are just a little bit too small to have formed into a black hole when they died. I'm sorry, you'll have to speak up. I'm having difficulty hearing you. Yeah, sure.
Alright, so there's actually some other cool stuff there. If a neutron star were to remain on its own in space without power out, that could also around for a very, very, very long time. We are talking quadrillions of years or even longer than that. Quantum processes cause the atom to slowly kind of join and eventually form life. And if they eventually form the entire element, which would be effectively permanent death. So neutron stars can actually evolve into absolutely active, terribly long time. And when they do are very, very long.
Sure.
My question is, how many planets are in the Milky
That's a tough question. And we actually, I don't have a good answer for you, unfortunately. We have so far discovered over 4,000 planets orbiting stars other than our sun. We call these planets exoplanets. And it's thought by the astronomy community that most, if not all, stars in our Milky Way will have at least one, if not more, planets orbiting around them. So there are about, I think, 200,000 stars in the Milky Way galaxy. And so you can assume that there's probably 200,000 or more planets just in our own Milky Way. Yep. And then when you start thinking about all of the other galaxies, they also have thousands or hundreds of thousands or millions of stars, and they also probably all have planets orbiting around them too. So there would presumably be lots and lots and lots of planets in our universe. Someone here is asking, will the universe die in 5 billion years? No. So you can all breathe easy. We are not dying in 5 billion years. That being said, though, the sun is going to die in about that long. So unless we can find some other planet to habit and some other way to get to that planet, it's very likely that 5 billion years from now, so really there's no reason to panic, when the sun dies, it will most likely be the end of life on Earth as we know it. Either the sun is going to swell so much that it will eat up the Earth, or it will get so close without actually swallowing it up. The radiation from the sun will be so much that life as we know it would no longer be able to exist. But we're talking 5 billion years from now, so you really don't need to worry. I hope it doesn't keep you guys up tonight thinking about that. These have been really wonderful questions, and I'd like to thank you guys all for joining us this evening. Hopefully, tomorrow our forecast will be stay better. It's been looking like it's going to be nice and clear tomorrow, so we'll be able to show that. And hopefully, too, Facebook is going to be working for us so that we don't have those technical issues as well. But feel free to join us again tomorrow. The links for the Zoom are exactly the same. So you can join us between 5:30 and 6 tomorrow, just like today. We'll start streaming right around 6 o'clock, but we'll open up the Zoom a little bit early so that people have a chance to log in. So thank you all so much for joining us this evening, and I hope that you all have very happy holidays.